Okay, we're back with our review for the Chem 4 final, and we're up to section 7, which is the Van Hof't factor. And we need to understand this because we're going to use it in our colligative equations and later on when we get to pH. What does colligative properties mean? It means as soon as we add a solute to a solution, that solution is going to have a different boiling point, freezing point, and osmotic pressure. We're not even going to look at the formulas right now, but I'll tell you all three of them contain I, and I stands for the Van Hof't factor. So you need to understand this. The Van Hof't factor simply means, will the solute that they add stay in one piece, or will it break apart into positive and negative ions? And if it breaks apart into positive and negative ions or particles, how many will it break up into? So we need to understand I, not only for the formulas on boiling point, freezing point, and osmotic pressure, but we're also going to see it later on in pH. So this is an important topic. So we need to understand which solutes ionize or separate into positive and negative particles in water. And there's a few categories. If you have a strong acid, they're going to ionize. If you have a strong base, that's going to ionize. If you have any kind of a polyatomic ion that contain oxygen, they're going to ionize. And the last category is the kind of salt that contains an ammonium ion. That's what NH4 plus is. And NH4 something. Those are going to ionize. So, now this is something that's going to help you for the rest of your chemistry life. I'm going to teach you a little rhythm for the strong acid, so you will always know what is a strong acid and a weak acid. It's vital now. It's even more vital when you cover pH. The strong acids have a strong acid. I call it a rhythm. Here's the song. Memorize it. HNO3 and HBr. H2SO4. HCl, O2, O4, say hi, strong acids all. HNO3 and HBr, H2SO4. HCl, HClO2, O4, say hi, strong acids all. Now watch. The hydrogens are the positives. So we're going to have how many particles? We're going to have the hydrogen, that's one particle, and then we have the negative part of the molecule, that's negative. So our I here is 1, 2. HBr, only one hydrogen, one Br, so the Van Hof't factor is 2. Now here's H2SO4. We have two hydrogens. We have one sulfate. So our Van Hof't factor is 1, 2, 3. HCl, one positive, one negative. Van Hof't is 2. HClO3, there's a poly, that stays whole. 1, 2. I equals 2. 1, here's another poly, 2. This is the negatives. The polys are the negatives. 1, 2. I equals 2. One positive, one negative. I equals 2. HNO3 and HBr. H2SO4. HCl, O2, O4. Say hi, strong acids all. Memorize that. It will save your life. Strong bases, and we call things strong when they ionize. in water. So what's a strong base? For strong bases, you're going to use the periodic table. In group 1, you're going to go from lithium to cesium. Any base with these and everything in between with an OH, that's going to be a strong base. In group 2, anything from calcium to barium, and since there are 2 positives, we need 2 negatives, OH2. These will be strong bases. For example, lithium hydroxide, cesium hydroxide, and everything in between. So what you remember for strong bases is the phrase Lix Kaba. Everything from lithium to cesium and calcium to barium. Everything in this group is going to have 1 OH after it. Everything in this group is going to have 2. Strong acids ionize, strong bases ionize, polyatomic ions that contain oxygen. Poly just means more than one. Examples, anything that contains like NO3 minus, SO4, PO4, 3 minus, you get the point. Anything where you see more than one poly, more than one type of atom, this has 4, with an oxygen, that's going to ionize as well. For example, HNO3, one of our strong acids, contains a poly. 1 negative, 1 positive, I equals 2. H3PO4 contains a poly. 3 positive, 1 negative, I equals 4. Last but not least, anything with ammonium, NH4+, for example, NH4 plus Cl. NH4 is 1 positive, the Cl is 1 negative, so the I equals 2. All right, how are we doing on time? Can you hit the small button on the, to the left, to the left, to the left? Hold. Hit it and hold. Oh, we still have time, 2 minutes. All right, so let's just try a couple, for example. NH4Br, NH4 2 SO4, Na2SO4, CaBr2, a protein or a sugar like glucose. You gotta move. Okay, here we go. Here's an NH4, 1 positive, 1 negative, I equals 2. NH4, 2 positive, 1 negative, I equals 3. Na2, 2 positive, 1 negative, I is 3. 1 positive, 2 negative, I equals 3. Proteins and sugars like glucose, I equals 1 because they do not ionize. They stay whole. So they go in as one particle. Now that we know the von Hof't factor, we can look at our colligative equations. So I'll see you in the next video.